Hello, I'm Mr. Malden, and this is the Middle School Math Toolbox where I teach you how to become a middle school math master. So if you're interested in that, hit the subscribe button down below. Today, our video, we're getting into vertical angles and linear pairs and just understanding the ideas of angles being adjacent to one another and also the idea that angles can be equal to each other or congruent, all right? So we're just gonna dive right into this and go over some different terms, all right? Let's start with adjacent angles, all right? Adjacent angles are two angles that have a common vertex and a common side, all right? So adjacent just means next to something, all right? So if we have this rubber band right here, and I say it's adjacent to my little eraser, I'm saying they're next to each other. All right, they're adjacent, all right? If I split them far apart like that, they're no longer adjacent to each other, all right? So in this image right here, you've got two angles. You've got D, E, F, and then you've got this other angle, F, E, G, and we're saying that they're adjacent to one another, all right? So we can use that knowledge to just create simple equations. This angle plus this angle is going to add up to the whole thing, all right? So adjacent angles are just angles that are next to each other, and you can use that information to help you write equations if you're trying to find a missing piece. Like for instance, if I were told this angle is 40 degrees and this angle is 60 degrees, then both of them together are 100 degrees, all right? Which is some quick math. You probably already could see that in your mind, but that's what adjacent angles mean, all right? They're two angles that are next to each other. All right, let's move on to the next one, linear pairs, all right? So if adjacent angles are next to each other, linear pairs are adjacent angles that form a line, all right? So linear, we think about things that can become a line, all right? And then pairs means two. So if you have linear pairs, you have two angles, all right, just like this. I've got two angles that are going to add up to the measurement for a straight line, which is 180 degrees. All right, so you have two angles that are going to add up to 180 degrees. And by nature, they are supplementary. All right, linear pairs are supplementary. All right, that's what supplementary means. If you need a video over supplementary and complementary angles, I've got one of those. You can go into my lessons folder and you can find the complementary supplementary angles one. But supplementary just means two angles add up to 180 degrees. Linear pairs, by nature, are supplementary because there's two angles that are going to add up to 180 degrees. And the way that we know that is because they're on a line, all right? In this image right here, you see you've got two intersecting lines. So you have, four different pairs of linear pairs. Angle 2 and angle 1 are linear pairs because they form a straight line. All right, and angles 3 and 4 are linear pairs because they form a straight line. All right, and then angles 1 and 4 and angles 2 and 3. So you've got multiple different pairs of linear pairs right here. All right, let's move to the next one. Congruent. The word congruent in math just means equivalent or equal. All right, the same as. All right, so when you have congruent angles, you have angles that have the same degree measure. All right, they're equal to one another. All right. When you have angles like in the image that you see up here that are separated from one another, they're not adjacent to each other because they don't have a common side and a common vertex. They're separate from each other. Then you're going to need some kind of statement to tell you that they're congruent. Otherwise, you can't just assume they're congruent. So if we have this angle as 60 and we have this angle as x, all right, and we're trying to find x, all right, well, I don't have any information right here in this illustration that I need to be able to solve this, all right, unless I have this kind of extra little equation that's given to us right here. This angle VWX, that's VWX, all right, is equal to angle JKL. Well, if that one's JKL, then this statement right here tells us that those are two equal, right? That those two angles are equal. And therefore, we know that if that one's 60, then that one also has to be 60 because that's just a 1x. And so if they're congruent, then that x has to equal 60, all right? So you're looking for that kind of statement in order to tell you that they're congruent. It could be a verbal expression, or it could be, you know, a statement in the form of an equation, just like that. Okay? So congruent angles are angles that are equal to each other, and we can use that information to kind of help us solve some questions. All right, so let's move on and let's take one of those examples. All right, you've got, I just changed the image. If you didn't see it, I changed the x on the inside of JKL to 2 x's. All right, so we have a new problem now. All right, we have this statement that angle VWX is equal to angle JKL. All right, we have that statement right here. Okay, and now I've got my diagram. I've got VWX, which is 60, and JKL, which is 2x. Well, if this statement says they're equal to each other, then I can simply take that angle and I can replace it with the expression that's on the inside of the angle, just like that. I'm going to bring down my equal sign, and then for angle JKL, I can replace that with the expression that's on the inside of that angle, all right? And then I can just simply solve it. Well, if 60 equals 2x, then if I divide by 2 on both sides, then 30 equals x, or x equals 30, all right? So you can, again, you can take statements like this, you understand that they're congruent, you can make an equation, and you can solve the equation. So all of the lesson right here with vertical angles and adjacent angles and linear pairs, all right, all this information in congruent angles, it's just knowledge that you can use to help you write equations, all right? Let's solve the next one. Let's do this next one. I want you to take, after you saw the example of me just doing that, I want you to take this diagram now, and I want you to solve for x. Tell me what x equals, all right? You can pause the video, you can come back, and you can see what the answer is. All right, so I've got angle VWX, which is 60, is equal to JKL, which is 3x plus 12. So what I'm doing right here is I'm just replacing the angle measures, or inside the equation right here, with the expressions that are inside the individual angle measures. And because they're equal to each other, then I can set these as equal to each other. And then I just have to solve by undoing the addition first, and then bringing down what I have left, and then undoing the multiplication by dividing by 3 on both sides, all right? And I find out that x equals 16, all right? So again, you're just needing to use the information that's given to you to help you create equations, and then you just have to solve those equations, all right? Let's go on to the next one. We got vertical angles, all right? Vertical angles are going to be congruent, just like we talked about in the last one. Congruent angles are angles that equal each other. Vertical angles are going to be, by nature, congruent because whenever you have intersecting lines, like this image shows you right here, I have one line intersected by another line, all right? Whenever I have intersecting lines, the angles that are opposite each other, all right, they only share a vertex. They don't share a common side. So they're opposite one another. They're across one another. Those are called vertical angles. So in this image right here, angle 1 and angle 3, they share a common vertex. It's right here in the center, all right? But they don't share a common side. So these angles are going to be considered vertical angles. And by nature, they are congruent, all right? They're equal to each other. Whenever you have intersecting lines, the angles that are across from each other are equal to each other, all right? So the measure of angle 1 equals the measure of angle 3, and the measure of angle 2 equals the measure of angle 4. And so we can use that knowledge to help us create equations when we're trying to find a missing piece and be able to solve those equations. All right, now we're going to decide, but you know, we have these 4 sets of angles. We're going to start up here at the first one, and we're deciding, are they considered linear pairs or are they vertical angles? All right, so we got 12 and 13. 12 is right here. 13 is right next to it, all right? And they together make up a line, so those are linear pairs, all right? I want you to try these other 3. Go ahead and pause the video and try the other 3. Tell me whether they're linear pairs or vertical angles, and then unpause it to see if you got the right answer. Okay, 13 and 14. Those are across from each other. They share a same vertex, but they don't share a same side, all right? And there's intersecting lines, so they're vertical each other and they're congruent. So for this question, just asking one or the other, it's vertical angles. All right, 12 and 15, they're also across from each other, so those are vertical angles. And then 12 and 14, they together share a side and a vertex, and they create a line, so those are linear pairs. All right, let's do that again, but now we're deciding, are they congruent or adjacent? All right, so if the angles are congruent, that means they're equal to each other. They're vertical angles, the ones that are across from each other. All right, or if they are adjacent, they're sharing a side and a vertex, and together they're making up, looks like a straight line right here. So number 6 and 9, all right? Number 6 and 9, they're across from each other, so by nature they're congruent, all right? So what I want you to do now is try the other 3 and see if you get them right. So pause the video, try them, see if you can come back and get them right. See if you got them right. All right, 7 and 8, that's the next one. 7 and 8 are also vertical each other, so they're congruent. And my screen's cutting off the T in congruent, but it's there, I promise you. It's just not there on the screen. All right, then we got angles 8 and 9 right here. They are adjacent to one another because they're next. They share a side, they share a common vertex. And 6 and 8, they share a side and a common vertex, so they're also adjacent. All right, so check your answers with that. All right, let's move on. All right, right here. What we want to do, or what we can do, and a lot of times you see this, all right, you may see intersecting lines like this, and you may see them, they only put one angle measure right there. And then using that information, you can find all the other angle measures, all right? So what I want you to do at home is draw the intersecting lines like this, put the 120 right here, and then try to determine what these other values are based upon your knowledge of vertical angles and linear pairs. Vertical angles are equal to each other. Linear pairs add up to 180. There's a huge clue. See if you can find these other 3 angle measures and then come back to see if you got them right. All right. If that one's 120, we know, because we have intersecting lines, that this also has to be 120 because it's across from it, right? And then this one right here, all right, we know that it makes up a line. It's adjacent to the 120, and it makes up this line right here. So we know if we do 180 minus 120, we'll find that angle measure, and its opposite is the same, just like that. So there you go. There's the angle measures. All right, let's go to the next one. Now we have, in this pair of intersecting lines, we've got an angle measure in one of them, and we have an expression in the other one. We've got the 3x degrees, and we've got 63 degrees right here. Now I can use that 63 degrees to be able to help me find out what these angle measures have to be. And whenever you're solving for a variable, all right, the first thing I want you to do is, before you ever start trying to work with that, just try to determine, what does that angle have to add up to? Do I have enough information in this problem to tell me what this angle has to add up to? And I do, because it's a vertical angle to this 63 degrees. So this angle has to be 63 degrees, all right? And therefore, we have 2 different ways that we are expressing the value of that angle, all right? 2 different ways, which means those are equal to each other, okay? So once you kind of label all the different angles, by the way, this one's going to be 117 because 180 minus 63 is 117, which makes that have to be it as well, right? But now we want to find out what x is, all right? So you're going to have to take these 2 values that you know that angle equals, and you're going to have to put them into an equation like this, 3x equals 63, to be able to solve for x. And then we would divide by 3 on both sides, and we'd find out that x equals 21. There's your math there on the screen as well. All right, let's move on. We got our last question right here. This is just a practice question. What I want you to do is, I want you to read the question, Okay, then I want you to solve for each one of those pieces. All right, it says what does x equal, what does y equal, what is angle QPS, what is angle SPT. All right, and we show our work as much as possible. So what I want you to do now is pause this video, try it yourself, get all those answers, and then come back to see if you got it right. Okay, first thing we're doing is solving for x. All right, it says solve for x and y, then find the measures of angle QPS and SPT when you show our work. So the first thing we need to do is solve for x. So if I'm going to solve for x, I am interested in the expression that has an x in it. It's that one right there, 9x plus 47. And I need to find out if I have any information in this problem that helps me know what that has to equal. All right, now I see this expression right here, but I want to know, is there information in the problem that would help me know what the angle measure has to equal in terms of like just a whole percent, all right, or whole degree, I'm sorry. There is information here because the angle that's across from it, when you have two straight lines that are intersecting, the angles that are vertical are congruent. So if this one's 146, then this one has to be 146 as well. So therefore, I can make that equal 146. So there's just two different ways to express that angle QPS. And then we're just going to simply solve this. Subtracting 47 from both sides, 9x equals 99. And then we're going to divide by 9 on both sides, x equals 11. All right? We find out here that x equaled 11. All right, let's create an equation to be able to find y. Okay, I'm interested in the expression for y. Now, is there information in the problem that helps me know what that angle measure equals in terms of just like a whole degree? All right, well, there is. I know this angle right here is adjacent to the one that's right next to it. All right, and together, those make up a straight line. All right, so I know 2y plus 146 have to add up to 180. Then I could take the 146 away from the 180 and find out that 2y has to be 34. Then I can divide by 2 on both sides and find out that y equals 17. So in this case right here, y equals 17. All right, now then QPS, all right, well QPS we already know is vertical of RPT, so QPS is 146 degrees. And then SPT, well, we already had to find that information out as well in order to be able to, solve for the y. We had to find that out. So SPT is adjacent to RPT, and both of those add up to 180. So 180 minus 146 is 34. So SPT is 34 degrees. All right. And that is the answers to this problem. All right. I hope you did well on this. If you had any questions whatsoever, you can put that in the comments down below, and we'll see you next time.